solving. So our first method that we're going to talk about is solving systems by graphing. So if you had to graph these by hand, your first step is if I were solving this system of equations by graphing, most people would solve this by putting them in slope-intercept form and then graphing. So your first step would be to solve both equations for y. Now, if you notice, we don't need to on the first one. It's already solved for y. So the second one, we would solve for y and then graph. Our second step, after solving for y, would be to graph both equations. So after you solve for y, after you graph, you find the intersection point. Which is going to be listed as xy. And then that is the solution.
Yes, sir.
Now, we've learned to graph these by hand. You certainly could also solve them both for y and graph them with technology. So with our TI graphing calculators, as soon as you solve both of these for y, you can put them in your calculator and find the intersection. One thing with computer technology in Desmos, you could put the second equation directly into Desmos and graph them and find the intersection point directly. So one of the downfalls of graphing, if you graph by hand, you're not going to necessarily be able to find an exact solution. You might have to estimate a little bit. So in looking at the second equation, we need to solve this for y. So what I'm going to do is up here, I'm going to add 4x. And then I'm going to add 4x. So we have 2y equals 4x plus 2. And then it's 2y, so we have to divide both sides by 2. And then I'm going to write the solution up here. We would have y equals 2x plus 1. So right now, I noticed something about those equations. What do you notice about the slope of both equations?
It's the same.
It's the same. What do you notice about the y-intercepts? They're different. So what can we say about the lines without even graphing them?
Parallel.
They're parallel. So if the lines are parallel, are they ever going to touch?
No.
No. So let's just graph those because it's good practice. So in looking at this one, the y-intercept is -4. So here's the origin on the graph. And then I'm going to go down 4. 1, 2, 3, 4. That's going to be my first point. And then up here, my slope is 2, which as a fraction would mean up 2 over 1. So back here, we go up 2 over 1. That's my next point on the line. And then up 2 over 1. And then I can just draw in my line. And then for my second one, my y-intercept is 1. So if this is the origin, I go up 1. And then my slope again is 2, which means we go up 2 over 1. And then up 2 over 1. So if I want to go backwards, you can actually go down 2, back 1. And same thing over here. So we could graph those, and then we would put no solution. So again, you could graph those by hand. You could also graph by technology. So that was the graphing method. Now we're going to look more at substitution. So for substitution, what you're going to do is solve one of these equations for a variable. So you can solve this equation for x, or you could solve this equation for y. Once you do that, you plug in your expression into the other equation and then solve. So to summarize the method, you solve one equation for a variable. And then the second step, you substitute that value into the other equation. And solve. So you solve one equation for the variable. It's called substitution because you substitute that value into the other equation and solve. That will get you one of the answers. So once you have one of the answers, we're going to look at the last step. Which is going to be use your solution to solve for the other variable. So again, that's just the process of doing that. And again, we need this skill of substitution a lot in math. So knowing how to substitute is going to be important moving forward. So if I look at this first equation, and we have equation 1 right here, I'm going to move this minus 2y to the other side. So I'm going to say that equation 1 is x equals 3 plus 2y. So we solve the first equation for x. Then what we're going to do is in this second equation, where we see x, we're going to put parentheses and substitute this value in for x. So up here, I'm going to put 2. And then instead of this x, we're going to put parentheses 3 plus 2y. And then I put plus y equals 6. And then the cool part that you notice, we don't have 2 variables. Now we just have 1. So what we're going to have to do here, distribute, simplify, solve. So 2 times 3 is 6, plus 4y plus y equals 6. And then what we're going to do, I'm going to subtract the 6 off. And I'm going to add my 4y plus y. So we're going to end up getting 5y equals 0. You can divide both sides by 5. 0 divided by 5 gives you y equals 0. So we have one of our variables. And now all that we need to do is solve for the other. So in choosing this, you can substitute into either equation. I'm going to pick this top equation because x is by itself as 1x. You could pick the other one just as easily. So I'm going to put x minus 2, and then instead of y, I'm going to put the answer, which is 0, and then equals 3. And then 2 times 0 is 0, so x minus 0 equals 3, or that would just simplify to x equals 3. Oops, and I put x equals 0. Let me just clarify that. So x equals 3. So now we have our solutions, and when we put our solutions together, we need to list them as an ordered pair. So our solution, yes, this would be fine. We have x, we have y, but the solution is together an x and a y where they cross. So if we list that as an ordered pair, it would be 3, 0. So 3 for x, 0 for y. And now we're going to move on to my personal favorite, elimination. So I like elimination the best. It's just how I like to solve the equations. But step 1, you need to pick to eliminate one of the variables by making opposites. So if I look at this equation, they are not opposites. How I can make opposites is I can multiply the top equation, all of the terms by 2, and then I would have 2x and negative 2x, and negative 2y and 2y, and negative 6 and 6. So again, here's the process. You choose which variable to eliminate. And multiply to make opposite coefficients. So again, pick which variable to eliminate, and then multiply to make opposite coefficients. That's how this works. Again, this is a little bit of a review from Algebra 1, but it never hurts to review how to solve these because, again, the more we repeat a skill, the better we have that skill down. So our second step is to add the equations. To eliminate a variable. And then your last one would be solve a new equation for a variable. So I'll let you catch up on writing that, and then I will model how to solve the top equation. So in going back, what do I need to multiply the top equation by? 2. So we're going to multiply this whole equation by 2. So in looking at that, I'm going to move this down here. 2 times x makes 2x. 2 times the minus y would make minus 2y. And then 2 times the negative 3 on the other side of the equals, of the equal sign makes -6. And then here we just write the bottom equation as we see it. We have -2x plus 2y equals 6. And now I like this because it brings me back to my elementary school days where we write the addition line and we just add them. So if you notice, 2x minus 2x is 0. -2y plus 2y is 0. We bring the equal sign down, -6 plus 6 is 0. Now, as I look at this is a true statement. When all the variables are gone and we are left with a true statement, there are infinitely many solutions. So this means any x or any y that you would, if you plug in an x, you could then choose a y or solve and get a y to figure out an answer. So this just means there are going to be infinitely many solutions. If you got a false statement, that would mean there's no solutions. So up here, infinitely many solutions. We are going to skip here with the step functions. And then we're going to talk about 3 vocab words: consistent, independent, consistent, dependent, and inconsistent. So first of all, ladies and gentlemen, consistent means that there are one solution. So if it's consistent, ladies, thank you. So consistent means that there is one solution. And that if there's one solution, you're going to have intersecting lines. So consistent means that there's exactly one solution and that graphically the lines will intersect. Now, there's another possibility besides having exactly one solution. You could have consistent dependent means there's infinitely many solutions. So you could also have infinite solutions. And if there's infinite solutions, it just means that you're graphing the exact same line. So, same line. And typically what you'd have there is, let's say we had in standard form like x plus y equals 5. If I multiplied the whole equation by the same number, it would stay the same equation. So let's say I disguised this and multiplied everything by -2. So if I had -2x and then minus 2y equals -10, these two solutions, if I graph them, would be overlapping lines. And they would be consistent, dependent, because they're the same line. And then inconsistent means no solution, and when we had no solution, we know that those are parallel lines. So now we're going to move on to the back. And we are going to talk about linear and nonlinear equations. So what we're going to talk about is how to solve linear systems of equations. And now we're going to talk about here, this equation is x squared plus y squared equals 25. That is a circle with a radius of 5. And then we have a linear equation, y equals 0.75x. That has a y-intercept of 0, and the slope, 0.75 as a fraction, would be 3/4. So we're going to look at actually graphing that by hand. We could also use technology. So step 1, graph the linear equation. Step 2, graph the nonlinear equation. Step 3, find the intersection points. Now, we're going to put this by hand, but to be honest with you, I think it's much easier to use technology, especially when you have linear and nonlinear. So let's start with the line. So first of all, I'm going to switch this to y equals 3/4 x plus 0, and then graph. So here's 0. And then my slope would be up 3/4. And then to work backwards, that we know that means down 3 and back 4 as well. So we could go down 3 and then back 4 as well. And then we can make a line. And then for my other equation, where we have x squared plus y squared equals 25. We know that the square root of 25 is 5, so that's a circle centered at the origin, looking at the equation. So the origin is the center, and then with a radius of 5. So here's the center of my circle, and I just go 5 in each direction, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then the same thing here and here. It's harder to tell where to put around my radius. And this is a convenient one for a circle. We could also graph and solve this with Desmos. So on here, this is going to be 4, 3 for my first intersection. So we have 4, 3 would be my first answer. And then over here, it looks like I'm at -4 for x and -3. And then what I do want to show you is how to also graph that on Desmos, because that becomes very simple. So on Desmos, we can just put the function in. We can put y squared and then plus x squared equals 25. And then we can put in our second function, y equals 0.75x. And you can see right here, here are the intersections, and it'll highlight them at 4, 3, and then at also negative 4, 3. So I just wanted to show you technology can also be very useful. There's going to be times when these circles and lines don't have convenient points that intersect right on points that you can find with a graph. So now we're going to talk about inequalities. So what we would do is step 1 is graph the first inequality. And then just a reminder, the type of line, if you have greater than or less than, you use a dashed line. And if you have greater than or equal to and less than or equal to, you have a solid line. And then the second part would be to shade appropriately. And then step 3 would be to graph and shade the second inequality. So in looking at the first one, we can look at this line. I notice it's less than, so we're going to have a dashed line. The y-intercept is 3, and then 2 as a fraction is 2 over 1. So if this is the origin, we start up 3, make a dot, and then go up 2 over 1, back 2 over 1, and then keep doing that. As a reminder, make sure you're careful with this. That's always a mistake that I make. I want to draw a solid line when it needs to be dashed. So dash it. And then I know if it's less than, you shade below the line. So we can just shade below. And I shade it lightly because our answer is going to be a solution region. And then for our second line, it's going to be a solid line, so I remember that. The y-intercept is -4, and then the slope is 1x, so 1 over 1. So if this is the origin, start at -4, -1, 2, 3, 4. And then the slope is -1, so down 1, back 1. And then you can reverse that, so up 1, or down 1, right 1, and then up 1, back 1. And then keep going. And then draw in a solid line. Oops, I made a mistake, so my apologies. And thank you for noticing that. I heard you guys say that. My slope is +1, and I drew one with -1. So sorry, I made a mistake. So up here, I go up 1, over 1 from my y-intercept, and that creates this solid line. And then here it's greater than, that means shade above. So my solution region is 1 right in here. So I also want to celebrate that mistake because mathematicians, we all make mistakes, teachers included. We are not perfect people. So we always help each other, read each other's work, look for mistakes. So snaps for a mistake. And then for the sake of time, we're actually gonna skip the maximizing and minimizing and the systems with more than two variables.